Hey there, science fans. Welcome to another exciting journey. Have you ever stopped to think about how amazing electricity is and how it impacts our daily lives? It powers our lights, our phones, our video games, and practically everything we do every single day. But have you ever wondered where electricity comes from, how it's generated, and how it gets to your house? Let's take a journey to learn about the electrifying world of electricity and its fascinating journey to our homes. Imagine a world without electricity. It's almost unthinkable. No bright lights to read at night, making evenings quite dull. No television to watch your favorite shows, leaving you with fewer entertainment options. No video games to conquer virtual worlds, which would be a huge bummer. It's hard to imagine, right? Life would be so different. Electricity is like magic, but it's even better because we can understand how it works and harness its power. So buckle up as we explore the science behind electricity and learn how this incredible force powers our world and our lives. Get ready for an electrifying adventure that will spark your curiosity. Let's start with the basics. Electricity is a form of energy that comes from tiny particles called electrons. These electrons are part of atoms, which make up everything around us. These electrons are always on the move, and when we harness their movement, we get electricity. This movement is what powers our homes, schools, and gadgets. Think of it like water flowing through a hose. The water is like the electrons, and the hose is like the wire. The wire guides the electrons, just like the hose guides the water. The faster the water flows, the more powerful the stream. Similarly, the faster the electrons flow, the more powerful the electrical current. This flow of electrons is called electrical current, and it's measured in units called amperes, or amps for short. Just like we measure the amount of water flowing through a hose in liters per minute, we measure the amount of electricity flowing through a wire in amps. The more amps, the more electricity is flowing, but electrical current needs a push to get moving, just like water needs pressure to flow through a hose. Without this push, the electrons wouldn't move. This push is called voltage, and it's measured in volts. Voltage is like the pressure that pushes water through the hose. The higher the voltage, the stronger the push and the more electricity can flow. High voltage means a stronger push for the electrons. So remember, electricity is all about the flow of electrons, and we measure this flow in amps and the push behind it in volts. Pretty electrifying, right? It's amazing how these tiny particles power our world. Now that we know what electricity is, let's see how it gets from the power plant to our homes. It's a fascinating journey that involves many steps and components working together seamlessly. Imagine a giant network of wires, like an electric highway, connecting power plants to cities and towns across the country. This vast network ensures that electricity reaches every corner of our nation. This network is called the electrical grid, and it's how electricity travels long distances. It's a complex system that requires constant monitoring and maintenance to function properly. The journey begins at a power plant where electricity is generated using various sources like coal, natural gas, nuclear energy, or renewable sources like solar and wind power. Each source has its own method of generating electricity. These power plants act like giant batteries, producing large amounts of electricity that can be sent out through the electrical grid. The control rooms in these plants are the nerve centers, ensuring everything runs smoothly. From the power plant, the electricity travels through a series of transformers, which are like booster stations that increase the voltage of the electricity. This step is crucial for efficient long-distance travel. This high voltage allows electricity to travel long distances more efficiently, minimizing energy loss along the way. Without this step, much of the electricity would be wasted. Think of it like this: it's easier to transport a large amount of water through a large pipe than through a small one, right? The same principle applies to electricity. Similarly, high voltage allows for efficient transmission of electricity over long distances. This ensures that the power generated far away can reach our homes with minimal loss. Section 4. Electricity in your home. Safety First Fuses, written by Bill Nye the Science Guy.